All right, so 1.4 is basically all about quadratics, but we are applying it to something, but also solving those equations, which is what you're going to do for the applications anyway. There's many methods for factoring, which we went over quite a few. So let's get straight to the solving. So looking at number 4, just ignore the equation part. If you're asked to factor this on just the left-hand side, what technique would you do? Or how would you start? Let's see here. Quadratic equations. And applications. Factor out the 2x and see. Let's go back to that question. Yeah, factor the 2x is the biggest factor. Factoring out just the x is not wrong, but you would need to also pull out the 2 because you want to get the greatest common factor. Okay, so number 1. In order to solve any quadratic equation, you have to factor. Okay. So here we go. Let me switch over in just a second. All right. So you factor 2x is the GCF. Now that they're factored, you can set each piece to 0. It's called the zero factor property. That's why we want to factor. When you have it equal to 0 and it's factored, you are allowed to set each factor to 0. This is called the zero factor property. You don't have to remember that, but that's why we were able to. So x is equal to 0. X is equal to -1. Any issues with the algebra from here to here? Let me see. When you factor 2x from both, oh, I see what you're saying. Yeah, I forgot the 2, didn't I? Right there. Thank you. Yeah, I just missed it. Okay, so then you would subtract 1, divide by 2, and get to here. These algebra steps okay, or do you want more details? Does it make sense? Now that it's correct. Just let me know. I can always show more details, no big deal. If I make no sense, just tell me. All right. So whenever we start, we said check for GCF. When you're factoring. When you are solving a quadratic equation, though, you got to make sure first it's set to 0 before you consider factoring, unless you're using a strange technique. So right here, just do basic factoring, like trial and error or AC method, either one. Or I think last time people said they wanted to do box method. That's fine with me. Let's do 6. Well, let's do 5 and 6. Who cares? Okay, so it's already set to 0. So we're good to start. First thing you check is there a GCF? I do not see one. So next thing we do is count the terms. If I have 3 terms, then we should do the AC method or trial and error or the perfect square. But trial and error, I think, is the easiest when there's no number on the X. I still need to send you that flow chart. I just remembered. I will. Factors of 4 that add up to 4 is only 1, right? That means that X plus 2 is equal to 0. X plus 2 is equal to 0. So same thing. So you only put one answer. Don't put both. All right, let's move on. Any questions on 6? Does this seem... I'm going to skip this guy unless you have a question. That one seem doable? All right. This will also be a Tron error. You just have to set it up first. Number 7 is a square root property type of problem. You could do difference of squares if you wanted to. I'll show you both ways. Excuse me. So if I were to square root both sides, whenever you square root both sides, you have to tack on plus or minus. Square root and square root cancel, leaving you with plus or minus 6. So basically this means that x is 6, x is negative 6. Now if I were to set it to 0 like we've been saying, subtract it over, factor, and then solve. See how it's the same deal? I don't care how you do it, as long as you show some work and your math is real, then you're good. Any questions on either method? This is square rooting both sides. This is just simply factoring using difference of squares. Number 8, the square root method is better. Let's check it out. Because I would have to multiply this out and then set to 0 and then factor, but here it's already a square, so what I could do is square root this. Tack on my plus or minus. Getting us to here. But now we have two possibilities when I add the 5 over. So what I recommend is writing it this way. So when I add the 5, I'm going to get 14 and -4, right? So is this equal to 9 or -9, right? Plus or minus. So therefore, I technically have two equations. Does that make sense? Okay. I'm gonna move on to a different technique. You guys cool on square rooting both sides? Trial and error or GCF? Completing the square is another technique. This one's kind of weird because you don't use it that often. I'll turn it just a second. This is number 9 on your homework. It says solve by completing the square. Now, technically you can use different methods, right? You don't have to use that, but if they tell you to use a specific method on an exam, then that's what they want. Okay, so complete the square. So basically what you're trying to do is find a special number that I can add to both sides in order to complete this square. So the way you find a special number is you take the b term. Remember that all quadratics are in general written this way. So you take this term, the b, and cut it in half and then square it. So this special number goes here. Okay. So b, in this case, is -8. Half of b is this. Half of b squared is this guy, right? Do you agree with this, the algebra here? So just put 16 here. So now this completes the square. So x squared minus 8x plus 16 is the complete square. The minus 9 we're just going to ignore. So this will factor into x plus, actually, minus. See how it turns out into x minus 4 twice? That's because it's a completed square. So now I have x minus 4 squared minus 9. So add the 9 over, and we end up with 25. I'll slow down here for a second. Do you understand the completing of the square and then the factorization and setup? Let me know if there's anything unclear, okay? It allows the factorization into this. Now, we don't use the technique very often, but it can be handy. We do use it when we're dealing with circles or like spheres. But other than that, it's very rare that I want to or need to use this, but it's going to come up in this section. So here we go. Back on the plus or minus. This cancels, giving me plus or minus 5. So again, this means I have x minus 4 equal to 5, x minus 4 equal to negative 5. And that's it. So we completed the square in order to square root both sides and find x. We solve for x. Any questions on the method? Oh, wait a sec. We'll start something new if you don't. All right. Now the completing the square is pretty much the same. The only times it gets a little more complicated I'll go ahead and show you real quick. We don't have to, we won't work it out, but right here, where is it? Here, see how there's a 7? You'd have to, there'd be one extra step here. So you would factor 7 out of the first two terms because it needs to look like this type. And then you start. So the setup would be pull out the 7. And if you factor 7 out of -2, you'd have 2/7. And then leave the, I gotta have a special number. Oh, wait. You see what I mean? So you set it up like this, and then you start. It's just that the b is a fraction now. Any question on that? Is that doable? If not, I'll move on to something else. Okay, cool. All right then. Excuse me. Now, if this is, if you complete the square on these guys, then it's easy to spot the graph. But of course, you could also graph it. The easy thing you can find right away is plugging in 0 to find your intercept. So anything that doesn't have a 0, -6 is automatically not the answer. So it looks like A is wrong because it doesn't hit. -6 looks like it's somewhere down here. This hits it. This C does not. D does. So it's either A or D. So you can either solve this to find the intercepts and see which one matches up with A or D. You can complete the square and then find the vertex and see where is that center point, that vertex value. But you can also use a graphic utility, right? Desmos or a calculator. It doesn't matter. You have any questions on finding x-intercepts on number 12 and y-intercepts? Do you remember how? Yeah, let's do one. Let me write the question down. This is number 12. Given y equal to x squared minus 5x minus 6. To find y-intercept, let x equal 0 and solve for y. This goes for any function. To find x-intercept, let y equal 0 and solve for x. So let's do the y, that one's easy. But let x equal 0, you get y equal to 0 squared minus 5 times 0 minus 6, which is equal to negative 6. This implies that the point 0, negative 6 is the y-intercept. Okay. X-intercept. But y equals 0. So you get 0 equal to this guy. So at this point, you're basically solving a quadratic. Okay. So solve it, find those two x values, and you're going to get two intercepts. So intercept is also a solution to the quadratic equal to 0. So solve this guy. Minus 1 plus 6. Yeah. So I don't know why I wrote that twice. So x minus 1 equals 0. X plus 6 equals 0. X is equal to 1. X is equal to negative 6. So these are going to be your intercepts. So you have 1, 0 and negative 6, 0 for x-intercepts. So that's how you find intercepts for any function. Any questions about any of these steps here? Okay, so that'll help you find parts B and C and D. And you can use this information to figure out part A, or you can graph it. All right, let's do one quadratic formula. Just in case. I'm gonna turn the page in a sec. Okay. All right. So quadratic equation requires the ABC for the formula. So A is 18, B is 9, C is -5. The formula for quadratic, basically, where the formula comes from is solving this guy. If you solve this equation in general terms, you end up creating this. It's kind of cool. If you can solve this in general and get this, then your algebra skills are on point. Okay, so plug all this in and solve for x. Plug everything in, see what you get. Okay, so now just simplify, see what we get. Uh, hmm. That'll be 81 minus 4 times 18 times 5. So this would be negative and then positive, right? Add this up. Root of 441, I had to look it up. I don't remember. Is 21. So it was a perfect squared number. Okay. We can factor a 3 into both, yeah. 3 times 12 is 36. So these will cancel. So we can reduce a little bit. So x is equal to -3 plus or minus 7 over 12, which means you have x equal to -3 plus 7 over 12, which is 4 over 12, 1/3. Or x is equal to -3 minus 7 over 12, which is -10 over 12, which is -5/6. So we have two answers. Any questions about any of the algebra along the way? From the beginning, you guys cool how we plug in the numbers? I'm sure you've done this many times in the past. But just a review here. Is there any questions on this? Okay, so that's pretty much it for this section. The very end has word problems, so let's look at that. Excuse me. My allergy medicine. Okay, so number 18. Write an equation for the area of the floor in terms of W. Find the length and width of the floor. Oh, they already have it in terms of W right here, right? So they did the work for us. So area would be length times width. So this would just simply be W squared plus 14W. Right? You guys cool with this one, part A? And the area is equal to 1800. So you would solve this. Solve for W here to get width and length. His length is equal to, right? So once you solve this equation, you're going to get two answers for W. But there should only be one W. So choose one that makes sense, the one that's positive, and plug it in here to get the length, and W obviously you'll have it once you solve this. Is there any questions on 18? Does that seem doable, or do you want to see the steps, or what do you think? Okay. Yeah, let's do it. Number 18. All right, so I'm gonna close this. So I'm hoping you have that open, that way you don't have to worry about it. So area for a rectangle is equal to length times width. Based on the diagram, width is just width, right? And width and length, sorry. Length is equal to W plus 4, which is length. They also said that the area is equal to 1800 in this question. So part A says write a quadratic equation for the area of the floor in terms of W. So either they want this, so I don't know if they want it written this way, or like this. This is same, it's just, I don't know how their preference. Oh, 14, yeah, you're right. So part A is that. Part B, solve for this. Well, actually, We will use this one. Set it equal to 0. That's how you solve quadratics. To subtract over the 1800. No, L is equal to width plus 14. Okay. So factor this guy. I don't know if that factor is pretty or not. If not, we're gonna have to do quadratic. Let me see. 1 second. It does factor pretty surprising. It's gonna be set each one to 0. Solve for W. So W is equal to negative 50. W is equal to 36. So obviously negative width makes no sense. So we want to use this one. So that means if W is 36, then length is equal to 36 plus 4, which is 14. 14. Oops. 50. Right? So that'll be part B. Any questions on the setup here? $50. When you factor this guy, basically you do the trial and error or AC method, and you try to figure out what multiplies to give me negative 1800, but adds up to 14. It just happens to be these two, but it's not easy to figure out. So I would recommend like quadratic formula, because that's like more formulaic. Or you can just kind of go through all the factors and find it. I'd probably just Google, hey, what is all the factors of 1800, and then find these two. This is what I did just because I'm being lazy. But with a calculator, I just try to find them all and write it down. This depends how you want to do it. Any other questions on this? All right, cool. This is a little harder. It's kind of, I mean, outside the box, I guess. Construct the open box from a square piece of material, cutting 2 centimeters. Okay. So they're cutting out all these little pieces. 1 second. Sorry. Let's take a short break. Getting a bunch of messages. 1 moment, guys. Let's take a 10-minute break. Let me show the picture one more time. So they mentioned volume. So volume is length times width times height, right? So the height is going to be length times width times that. Okay, so here we go. Using all that information, excuse me. We know that volume is equal to height times width times length. So the volume of this box is going to be, if we're cutting out the corners, it'd be x minus, hold up, noted by h. We don't know h. Let's just think this out here. I don't see it just yet. But I'm thinking the height would be h times width would be x minus 2h, because I'm subtracting it, times the other length would be the same, x minus 2h. Okay, that's what I'm understanding here. We have V, volume. Oh, here it is. H, they did give us H in the problem. My bad. I was like, how I can't solve this without H, but they said 2 centimeters. So H is equal to 2 centimeters. Volume is equal to 392 centimeters cubed. There we go. Now we're good. So volume will be at 2 centimeters times x minus 2 times 2 centimeters, x minus 2 times 2 centimeters. So that'll be, I'm just going to not write the centimeter just because it's kind of messy. 2 times x minus 4 times x minus 4. So that'll be 2 times x minus 4 squared equal to 292. Double check my work here. Seems like something's wrong. Or maybe I'm overthinking it. X minus 2h, x minus 2h. We're folding it up by h. So that should be the height of the box created. So that's not wrong. Logically, it makes sense to me. Find the dimensions of the square piece of material. Knowing the volume. Yeah, it just doesn't seem right in my head. Let me check the answer. I feel like this is wrong. I could be right, but this doesn't seem right. Number 19. Let's see. Okay. Yeah, I think I'm just overcomplicating it. Let's go. Yeah, let's start over. There's a calculus question that's just like this, and I was thinking it was something like that, and it's not at all. That one is way more complicated. And this is not. Because they gave us a picture of the box. It legit said I had the box, hold it up with X and X as the base, the square box, and then the height of H. So that means the box would simply be 2 times X times X. So that would mean that 2X squared is equal to the 588 centimeters. Is that what we had, or was that different? What was our volume? Because I erased it.
392.
392?
Yeah.
Okay, so this was given. H was given. So if you just do this, divided by 2, 392 divided by 2, what's that going to be? Okay. 96, right? Screw both sides. So X is just 14. So that means, looking at that diagram, right? The width of the piece of material before they cut it into a box, the width would be X minus 2H. Length would be the same. This is a square box. So we would have 14 minus 4. So 10. 10 by 10. Does that make more sense? Because I think I was overdoing it. Okay. Let's use the rest of the time to go over homework. Which assignments had closed? Somebody asked they needed a extension. Let me see. P234 will be due Thursday. One, 4, and 1, 5 will be due next Monday. Might be adjusted later. Oh, quiz 1, yes. I think I adjusted quiz 2, but not 1. Let me see. Was it quiz 0? Oh, here's quiz 1. Okay. That'll be due Friday, quiz 1. Okay. Yeah, so they're all open, so use the rest of the time to work on it. Let me know if you have any issues or questions. Okay.